Hi students, today I am going to explain two problems which are very similar to your LU9 homework problems. So let us focus on the first problem here. Basically, we need to complete this table. There are some blanks which we need to complete in this table. So you can see here, first row is for treatments, second row is for block, third row is for error, and the last row is for the total values, right? And then we have a degrees of freedom in first column, some square values in second column, mean square values in third column, f value in fourth column, and then we have p value in the last column. All right, so first thing is we need to find out this value here for the block, degrees of freedom for the block. So if you go to table 4.2 in the book, all the formulas is given in that table. For example, treatments degrees of freedom is a minus 1. So we will basically calculate the values. Degrees of freedom for the treatment is a minus 1, right? So we're gonna a minus 1 is equal to how much? 3 here, right? 3. That means a is equal to 4, right? Now next is for blocks we don't have value in the table here, so we look for the error. For the error, degrees of freedom for the error is a minus 1 multiplied by b minus 1, right? So a minus 1 multiplied by b minus 1, which is equal to 9, right? And we know that a minus 1 is equal to 3. So 3 multiplied by b minus 1 is equal to 9, right? And b minus 1 is equal to 3, thus b equals to 4, right? B is equal to 4, and degrees of freedom for the block is b minus 1. You can see here b minus 1. So 4 minus 1 is 3. So we completed the first blank here. Now for the sum of squares, it is same as we did in I think chapter 2. The total value is the sum of all these three, right? So to find out SS block, what we need to do is we need to add these two values and subtract them from this value here, right? So let's do that. Sum square for block is equal to 265.438 minus 78.063 minus 22.188, right? This is equal to 165.187. So we can put this value here, 165.187. Also we can check the correctness of this value. We know that the mean square value is sum squares divided by degrees of freedom, right? Sum square of blocks divided by degrees of freedom for the block. So if we divide 165.187 by 3, we should be getting this value 55.0625, right? Now also this value can be calculated by dividing some squares by the degrees of freedom. So 22.188 divided by 3, 7.396. Similarly, mean square value for the error is 78.063 divided by 9, which is 8.673. Now we need to calculate the f value, and f value is mean square for the treatments divided by mean square for the error, right? So mean square for the treatment is 7.396 divided by mean square for error is 8.673, which is equal to 0.853. Okay, now let us focus on this f value here. What is this f value? This f value is basically based on the treatments and error, right? And there are, as we know, there are two parameters for f distribution, and they are degrees of freedom for the numerator and degrees of freedom for the denominator. So we used mean square value of the treatment in the numerator and mean square value of the error in the denominator, right? So we have a first degrees of freedom for f is 3 for the treatment, and the second degree of freedom, the degrees of freedom for the denominator is 9, right? So basically this f value is equivalent to f value at a minus 1 numerator degrees of freedom and a minus 1 multiplied by b minus 1, which is 9 denominator degrees of freedom, right? So basically f value at a minus 1, the numerator degrees of freedom is 3 and the denominator degrees of freedom is 9, right? So at f this f value is 0.853, right? Now we know f value, we know degrees of numerator degrees of freedom and the denominator degrees of freedom, and we need to calculate the p value, right? So I will calculate this p value using Excel. So what I will do is use function f distribution. Here it is, you can see f distribution x degrees of freedom 1 and degrees of freedom 2. X is the actually value of the f value at that point, right? So my x value is 0.853, 0.853. First degrees of freedom is here 3, right? And second degrees of freedom is 9. So 3 and 9, and I have a value of p, which is 0.5. So I put 0.5 here. Now we have completed all the blanks here, right? So this is all about question 1. Next I have a question which is similar to your second question in your homework. Let me read this question and then we will solve this. A chemist wishes to test the effect of 4 chemical agents on the strength of a particular type of cloth. Because there might be a variability from one bolt to another, the chemist decides to use a randomized block design with the bolts of cloth considered as blocks. She selects 5 bolts and applies all 4 chemicals in random order to each bolt. The resulting tensile strengths are shown in the following table, right? Analyze the data from this experiment, and we can use alpha equals to 0.05 and draw appropriate conclusions. So basically, in this design, experimental design, what we want to know whether the chemical agent has an effect on the strength of the cloth, right? So we have 4 different chemical agents, and there can be a variability from one bolt of cloth to another. So basically, the bolt of cloth, she used 5 bolts of cloth, right? So these bolts are, what are they? They are the blocks, randomized blocks in our experiment, right? So we have a factor which is chemical agent, and we have another factor which is randomized block, and we have all these readings here, right? So I will solve this problem using Minitab. I already opened the Minitab here, and I have already entered the values. So now most important thing here is to look at how I entered those values. This 73, there are basically 5 multiplied by 4, 20 observations, right? So I entered them in first column. Like, I took this column first, 73, this first column here. I copy pasted it here, right? Then the next column, and 1 to 20, you can see I entered all the readings of the strength. Next is block, which is the bolt of cloth, right? So I entered the values. So first 4 readings, what was the block or the bolt of cloth? It was 1, value of 1, right? So I have 1 for the first 4 rows, 2 for the next 4 rows, and so far, like a 3 for the next 4, and so far and so forth, right? Next column, the third column, is the treatment. What are the factor, what are the treatment? Basically chemical agent, 1, 2, 3, 4, right? So I entered values 1, 2, 3, 4 for first 4 rows. Then again I repeated 1, 2, 3, 4, and similarly you can fill in the rest of the column, right? Now last few homework problems, you used ANOVA, and then you used one-way unstacked ANOVA, right? Now there is a difference. Now we have two-way ANOVA basically this time, because we have a block and then we have a treatment, right? So the procedure is little different. We're gonna go to stat, go to ANOVA again, but rather than using one-way ANOVA, this time we will use two-way ANOVA, right? Now see here, we have 3 columns representing, one column is representing the strength, the actual reading, observation of the experiment. Second column representing the block, which is the bolt of the cloth, and third column representing the chemical agent, the treatment, right? So our response variable is strength, so I'm gonna select that and put in here the response variable, right? Our row factor is the treatment, right? This is our row factor. It doesn't, it does not matter if you put treatment as a row factor and block as a column factor, or if you put block as a row factor and treatment as a column factor, it doesn't matter. But I'm going to select treatment and put as a row factor, and then I'm going to select block and put as a column factor, right? Next is we have been asked to use alpha is 0.05, that means 95% confidence interval, that is right here. And in this question, even though they did not ask us to draw the graphs, in your homework question you are supposed to draw some graphs. So I will also show you the different graphs here. So let's go to graphs. We can plot normal plot of residuals. I think this is one of the questions that I asked in your homework. And we can plot some other graphs here, as you can see, but I'm not interested in them. Now I want to plot the graph of residuals versus the variables, right? I'm interested in plotting the residuals versus block. So I will select block. And I am also interested in another graph, which is residuals versus treatment. So I'm going to select this treatment here, and okay, right? Now so now we are going to plot three graphs, as you can see: normal plot of residuals versus block, and residuals versus the treatment, right? And I hit OK. So we have results here, as you can see. So let's look at these results. We have a p-value of 0.121, and this value is greater than value of alpha, right? Alpha is 0.05. That means, what does that mean? That means we cannot reject null hypothesis, and there is no difference between different chemical agents. They do not affect the strength, right? Now finally we need to look at the graph. So see the normal probability plot of the residuals, and we can see that they are consistent around this straight line, so the assumption of normality is good. And this graph here, residuals from strength versus treatment, which is chemical agent, and more or less it looks consistent to me. The variance is consistent. That means that shows uniform variability, and also that shows that all the different chemical agents are same, right? So that is all about problem 2. Good luck on your homework LU9, and I am extending